So this is the part two of area between curves, and I'm going to solve two problems to illustrate the concept of area between curves. Please take a good look at this picture. So what we have is a parabola and a straight line, and we are expected to find the area between these two curves. Okay, the first order of business in all these problems, and this is a key, is to figure out which way to orient our representative rectangle. And I would say we should orient the rectangle vertically because that way, when we move all the way from left to right, which is what you do when your rectangle is vertical, you are saying that you're going to integrate from left to right. On the other hand, if your rectangle is horizontal, you are integrating from bottom to top. In this case, if we orient vertically, then the top of the rectangle will be touching the parabola and the bottom of the rectangle would be touching the straight line all the way from left to right. As we scoot this rectangle all the way from left to right, that's what would happen. However, that is not what would happen if this were to be a horizontal rectangle, because say somewhere over here, the right side would be touching the straight line and the left side would be touching the parabola. The same rectangle, when scooted over to say some position here, would be touching this right side would be touching the parabola, right half of the parabola, and the left side would be touching the left half of the parabola. And you want to avoid that. So the orientation is the first thing that you figure out. And the moment you draw that rectangle, immediately be sure to draw those vectors that show x and a dx. I say vectors, but they're just show that this is the distance where the location of the rectangle rather is at a distance of x from the origin, and the width of the rectangle itself is dx. Simple? Cool. Now, when you have a rectangle like this, can we find the area of this rectangle at this stage? I would say yes, because all we need is the width of the rectangle and the height of the rectangle. The width of the rectangle is clear, dx. Height of the rectangle, maybe that's the little difficult part. But but you would agree that the differential area, that means the area of this itty bitty rectangle, is h times dx, right? And now, when we want the entire area under the curve, all we need to do is integrate dA. When you integrate dA, you get A. Well, you integrate dA specifically from a certain x value equals A to a certain x value equals B, you get the area in that interval, area between the curves in that interval. As if you change the interval, that means you're changing the area that you are looking at. So when we integrate from A to B, we are finding the area from x equals A to x equals B between these two curves. Cool. So going back to what in the world is that h? H is this height, right? How do we find the height of this rectangle? Notice, are we measuring the height in a vertical direction? Right here, the height is from the distance from this line segment to this line segment. That is h. Since the measurement is being done in a vertical direction, if you want to get a positive value for h, you should take the y value at the top, and from it, you should subtract the y value at the bottom. Okay, that is the key. To get a positive value for the height has to be positive, you adopt a simple strategy. The y value at the top minus the y value at the bottom. Now, what is the y value at the top? Well, notice this point happens to be a point on that parabola, 5x minus x squared. So the x coordinate at this point is x. That's why we said this is x. So the x coordinate is x. So the y coordinate must be 5x minus x squared. right? So 5x minus x squared is the y value here, and by the same argument, x is the y value here, simply because this curve is y equals x. So this point has an x value of x and a y value of x as well. Okay, so we would have a equals 0 to b equals 4, right? The x value here is 0 and the x value here is 4. So a is 0, b is 4. And h is 5x minus x squared minus x. That is precisely what I have here. And the rest of it is straightforward. Integral from 0 to 4 of 4x minus x squared, and you get 32 over 3. Simple? I think so. So next thing, I'll pick up another problem and show you how to do this. Take a look at this. So here, we're supposed to find the area between this red curve and this other curve. Oh man, is that green? I'm pretty lousy with colors. Uh, Dark green or is it just black? I have no idea. Whatever. So the dark curve and the red curve. And also there's some limitations on the in the y direction as well, in the vertical direction. So we need to figure out from this line segment to this line segment. So the interval from y equals 0 to y equals 1, and between these two curves, what is the area? Okay, if you recall, the first step in this process is which way should we orient the rectangle? I'm sure you would agree that the rectangle needs to be horizontal, which means we are going to integrate all the way from the bottom to the top. Okay, so immediately draw y and a dy. So the rectangle is located at a distance of y from the origin or from the x-axis, and it has a width of dy. And the differential area is, in this case, h times dy. H, what is h? H is the height of the rectangle. Height is probably not a good word to use in this case. The width of the rectangle, right? I'm still denoting that with an h. If you want to call it as w in case like this, please feel free to do so. So the h value of the rectangle is this one. Let me show that. Yeah. Now here again, we want h to be positive, right? But we are measuring h in a horizontal direction. You agree? Because of that, in order to get a positive value, this is what we must do. We must subtract from the right side value the left side value. For example, I'll give you in terms of numbers. Let's say this were to be 3 and this were to be -2. What's the distance from here to here? 3 minus -2, which is a total of 5. So always horizontal, especially when you have a coordinate system where horizontal is x, to the right is positive. You want to get a positive value for h, the right side value minus the left side value. Okay, that's all. If you keep that in mind, you are never going to make mistake in this problem. So here we are integrating from y equals 0 to y equals 1. So c is 0, d is 1. H is square root of y. The right side value is y, square root of y. And the left side x value is y square minus 1. Okay, let me repeat that one part just a little, please. The height, this h, is the x value at the right point minus the x value at the left point. So the x value at the right side is square root of y. The x value at the left side is y square minus 1. That's what I did. Cool? That's all.